Hello students, welcome to Physics Pathshala. Today we'll study class 11, chapter 2, that's our units and measurement, lecture 1, that is units and system of units. This unit is linked to measurement of any item or object. Measurement is very important term related to physics. As we know, physics is branch of science in which we study nature and natural phenomena. Phenomena are day to day happening in nature or the activities going on in nature, that is the natural phenomena, and study of these nature and natural phenomena is termed as physics. And science, we know, study of any subject in a systematic way. Systematic means through observation, experiment, and finally expressing in mathematical formula or equation. This mathematical formula equation helps us to predict what is going to happen through this controlled experiment. We find out this final conclusion, and this controlled experiment done after a systematic observation of these natural phenomena. Like example, when any object is dropped, it falls towards ground. After a number of observation is found out that the object comes towards earth or ground due to the force of attraction by earth, or later it is termed as this force of gravity. Likewise, in all the activities happening in nature can be expressed in a mathematical formula so that we can predict or we can use for our own requirements. In that, in all cases, we need measurements. Like, if you want to reach somewhere else, if you know the length, if we want to reach at any point after a certain distance from any starting point A, want to reach that point B, and distance is L, and want to reach within certain time T, then we have to move with a certain speed, that is L divided by T. Likewise, we'll be requiring measurement in all steps in physics. This unit is linked to measurement. Measurement of what? Measurement of any quantity that will be used in physics. That is any quantity or any item, any quantity that can be measured is our main concern. This quantity will be termed as physical quantity. This quantity will be termed as physical quantity. Any quantity that can be measured will be termed as physical quantity in physics. Here, this physical quantity now is termed as the quantity that can be measured. Secondly, this physical quantity will help us to express laws of physics. That means with help in terms of physical quantities, we can express laws of physics. Through these laws or mathematical formulas, we can understand easily the nature and natural phenomena, natural happenings. These laws of physics can be expressed in terms of or using these physical quantities. These physical quantities can be always measured. It will have certain value. Measured means it will have certain value. If you measure, you will get some value. Those quantities will be termed as it can be measured, or in physics you will term those quantities as physical quantities. Hence, physical quantities are the building blocks of physics. Without physical quantity, we can't study physics. Hence, it is the building block. Using this physical quantity, we will be studying full physics, or we will be able to understand to whole physics. We have in number of physical quantities. Out of them, only few are basic or fundamental quantities. These are base quantities or fundamental quantities. We had three physical quantities as fundamental quantities. Later four added. Now it became seven fundamental quantities. The remaining quantities in physics will be termed as derived quantities. That means all other quantities will be formed after combination of these fundamental quantities. Fundamental quantities are the independent quantities. That means they don't depend upon any other and other quantity while expressing it. That means these are independent quantities, whereas derived quantities are dependent quantities. That means they are expressed after certain combination of these fundamental quantities. These fundamental quantities are mass, length, time, and let us trace electric current, temperature, luminous intensity, and the last one is amount of substance. All these fundamental quantities can be measured. Now the term what is measurement? Measurement it says measurement is a comparison. While doing measurement, we find out the item to be measured, how big or small with a certain fixed standard. That means measurement is the term that is comparison done in comparison done with certain uh, smallest basic standard. Then the result is or in measurement the final result is how many times how many times it is bigger or smaller, how many times bigger or smaller to that basic standard. That means suppose we have one big item and we want to weight want to find out what is the weight of this or mass of this item. Then we what we'll do, we'll compare it with a standard mass, suppose that is 1 kg, the standard one, and this will be how many times bigger than this small one. Suppose it is 10 times, 10 into small object. This big object is equal to 10 times than this small object. Here we found the small object is taken as unit and this number is some numerical number. It's a numerical number and associated with unit. That means anything will measure. Final result is measurement says we will get some numerical number and its unit. In every measurement, the result will be certain numerical number and unit. Unit is nothing but the smallest basic standard with which the bigger one is compared. These units have been assigned to these fundamental quantities. Unit of mass is kg or kilogram or gram. Unit of length will be meter or centimeter, and unit of time will be second. Now, these units are the smallest one accepted internationally, and everywhere in physics will compare with these units. If it is kilogram, meter and second, this type of system in which we will use kilogram as unit of mass, meter unit of length and second unit of time, that system will turn am, k and s. This is termed as system of units. That means system of units is a complete set of units. In this, we have meter, mass, and meter, unit of length, kg, kilogram, unit of mass, and second, unit of time. That's a complete set. Using these three, we'll be able to express or able to measure all of the quantities in physics. That's why these forms a set of units. This set of units in which meter, kg and second is used, termed as am, k and s or mks system of units. In another way, when gram is taken as unit of mass, centimeter unit of length, and again second unit of time, in that system of units, mass will be measured in terms of gram, length will be measured in terms of centimeter, and time will be measured in terms of second. The initial terms of these units, CGS, CGS, then this system of units is termed as CHS system of units. Now we got MK system of units. M is the first letter for meter, K first letter of kilogram, S the first letter for seconds. And all these first letter of these units formed MKS. Then this system of units named as MKS system of units. Similar way, CGS is termed as the CGS system of units, where first letters are centimeter, for centimeter C, for gram G, and for second S. Another system of units is FPS. FPS system in that unit of length will be foot, initial letter is F, unit of mass will be pound, initial letter P, and second unit of time will be second, that is, hence it forms FPS or this system units is termed as FPS. Now, this MK system is modified. Modification is done by adding four other fundamental quantities. Earlier we had one, two, three fundamental quantities. Fundamental base quantities were mass, length, and time. Now four other. Fourth is electrical current. Fifth is temperature. Sixth is luminous intensity, and seventh is amount of substance. These four fundamental quantities are added. Unit of electric current is ampere. Unit of temperature is Kelvin. Unit of luminous intensity is candela. And amount of substance is mole. Symbol for this ampere A, Kelvin K, candela C, small d, and mole is MOL. Now, this new system of units was formed considering seven physical quantities is termed as SI system of units. SI system is International System of Units. International System of Units, in which unit system of units we have now seven fundamental quantities. That means other than these seven fundamental quantities, the remaining quantities we use in physics will be termed as derived quantities. Those derived quantities will be formed after combination of these fundamental quantities. Now, unit of these fundamental quantities are termed as fundamental units. These units, unit of mass, unit of length, unit of time, unit of electric current, unit of temperature, unit of luminous intensity, and unit of amount of substance will be termed as fundamental unit. In similar way, unit for all derived quantities will be termed as derived units, and these derived units will be formed after combination of these fundamental units. That means derived units are nothing, are those units formed after certain combination of fundamental units. Summarizing what we have studied, we have studied what is measurement, what is physical quantity. Then we studied what is unit and what is system of units. Measurement is nothing, a comparison with certain basic standard. Basic standard, basic standard that is termed as our unit. That means the final measured result is certain numerical value times unit. This unit is the basic standard internationally accepted of same kind. Same kind means when you want to measure mass, unit will be kilogram or gram, not meter. Similar way, when you want to measure length, unit will be meter or kilometer, not gram or second. Same, when you measure time, you'll be using second, not gram or meter. That says the smallest quantity of same kind that will be taken as basic standard reference, with which the bigger one or item to be measured will be compared to get the final result. That is measured value or result. Result or measured value will be always some numerical 1, 2, likewise any value, 2.5, any some numerical value times the unit which we have considered or taken as reference. Then physical quantity is nothing. Any item that can measure will be termed as physical quantity in physics. Physical quantity are of two types. One is fundamental quantities and another is derived quantities. Fundamental quantities we have taken 7 numbers in SI system, and remaining quantities are formed after correct arithmetic combination, addition, subtraction, multiplication or division of those fundamental quantities, then we get the derived quantities. Unit of this fundamental quantity are the fundamental units, and unit of derived quantities are derived units. That means derived units are nothing but arithmetic combination. Arithmetic combination of fundamental units, we get derived units. That is, to find unit of any fundamental quantity, suppose our fundamental quantity is force. Force is no mass into acceleration of a moving object. In that case, F is equal to ma, and unit of force will be unit of mass multiplied with unit of acceleration. Unit of mass will be kg, and acceleration is length per time square. Kg into length is meter per second square. That means now once you want to measure the force, this is a derived quantities. Now we did multiplication of fundamental quantities, that is mass, then length divided by time square. In that case, unit of mass became kg, then unit of length meter, and unit of time seconds. That means it became a arithmetic combination of units of fundamental quantities, or arithmetic combination of fundamental units. This is a fundamental unit, this is fundamental unit, and this is another fundamental unit. Now we got Unit of force is k centimeter per second square, or we say 1 Newton. And the last one is system of units. System of units, we had MK system, we had CGS system, we had FVS system, and we had SI system. In MK system, unit of fundamental quantity, that is mass, another is length, and another is time. In MK system, unit of length will be meter, mass kilogram, and time second. In CGS system, unit of length will be centimeter, mass will be gram, and time, unit time will be second. CGS. And in FPS, unit of length will be foot, pound, and second. In SI system, it is a modification of MKS. For all these three, unit of MKS remains same like as it is. For length, it is meter. For mass, it is kilogram. For time, it is second. Additionally, four other quantities are added. That's for temperature, Kelvin. For electric current, that is ampere. Luminous intensity, that is candela. And of substance amount of substance is mole. With that, we could that covers our system of units. With this, we'll be able to find out a number of we'll be able to find out unit of a number of derived quantities or derived units. The derived quantities, once you know its formula, how it is, this formula says how it is mathematically dependent upon the fundamental quantity. Once we know formula of any derived quantity, that means the mathematical formula or mathematical combination of fundamental quantities, then we can find out unit of the derived quantities.